Hello, welcome to the first lecture for the PIA6204, Statistical Analysis for Public Policy and Management. I'm Dr. Yanto Chandra, Associate Professor in the department at CTU, and I'll be your course leader. So we're going to go through today's lecture in 5 different parts. So in this week's lecture, we're going to look at the foundations of research methods. Before you get to know how to do statistical analysis as part of doing a research, it's important to have foundations of what it means to be engaging with research methods. So we will divide these foundations into these different parts, into different videos. So this is the first part. In the first part, we're going to talk about truth. Right? How do you find truth? How do you know you have found some truth through the research that you are working on? One of the easiest way to understand about truth is to look at what happens in the field of medicine. So if you have seen how doctors are doing the work, they won't rely on their feelings, they won't rely on their emotions to provide a solution to the patient, but rather they need to have evidence in terms of whatever kind of evidence that is possible, that is the best, that is available for them to provide care. For example, blood, pulse, any kind of respiration function using this stethoscope, blood analysis, X-rays, ECG, MRI to scan your head. So they use all kind of devices to create evidence, and using the evidence, then they will use it to make a decisions about how you treat some sickness in the patients. In the same way, perhaps in the past 50 years or even longer, there has been a trend for the social sciences to adopt what we call evidence-based approach. So for example, if you're studying public policy or if you're studying business, there's this called evidence-based public policy or evidence-based management and things like that, in which researchers rely on evidence in order to make decisions, to advise policymakers, to advise decision makers, to advise chief executive officers on what to do. So you have seen there are more and more surveys are being done. People are taking large sets of data, for example, from social media in terms of how you are connected with each other and what you talk about in the social media. That's the middle one with the green lines. And you also seen more and more social sciences research are adopting very cool technologies, right? Such as using the eye tracking, for example, in research on how people, to understand how people read materials on the computer or on their mobile phones. You can use this eye tracker and it will give you these heat maps, which tells you where are the locations that each individual and the entire sample of people that you are studying, where they are looking at. And that will give you a lot of useful evidence and also suggestions in terms of what you can do. And also more and more devices are being put on people's pulse, on people's sweat, on other parts of human body to understand about the phenomena. Now, if you look at what happens in terms of social sciences, these are the steps that you could say what people do in adopting scientific methods to address a particular problems. For example, you start by observing some reality, and then you try to ask, what is the question? What is the problems here? What are the debates here? What are the unresolved puzzles here? For example, you have new types of diseases, or you have type of social problems. So after you observe them, then you ask the question, why? What exactly the question? Why did we have that social problem? Why did we have that disease problems? And then people will start to come up with some hypothesis. Oh, these are the possible explanation for this disease, for this social problem, and then they collect data, and they go to the fourth step to actually test this result and try to come up with some conclusion, and then they will report the findings. So in this course, we're looking at actually all of them with a specific focus on step 3 and step 4 and step 5, which is looking at the how you come up with a theory, that is the hypothesis, and how you test them and how you report the findings. Now, in terms of where is the boundary? So if you look at what kind of research that we do in social sciences, in the past, people make a very clear distinction about natural sciences versus the social sciences. But if you look at what happens nowadays with how social scientists do their work, there is actually very little difference between the methods or the scientific inquiry approaches used by natural scientists in the labs in engineering and sciences compared to those in the social sciences. The difference is very minimum. And perhaps what makes the crucial distinction is the object. Like if you are in engineering or sciences, you might look at atoms, very small thing, nanomaterials, you look at cells, you look at materials, versus in social sciences, we are looking at humans, we're looking at groups, organizations and society. So that's what we look at in terms of scientific methods. Now, let's say you have some people who claim that, wow, if you eat spicy food, it can make you live longer, right? I like to believe this because I love spicy food, right? If you do love spicy food, I'm sure you will think, well, if there is such claim, that this is cool, this is fun. But this may just be a claim, right? Spicy food makes you live longer. Now, the question is this just a claim or is this a truth? Now, if this is truth, how can you test this? So at the start, when someone tells you this, then you should not take this as a truth, right? This is just a claim that eating spicy food can help you live longer. But how do you test this claim? What kind of data, what kind of analysis that you need to test this claim? So the purpose of taking this course is to get you to be able to think about what you need to do in order to test some claim, in order to get closer to the truth. If you are the kind of person who don't care about truth, who don't like about truth, maybe this is not a very useful course for you. But if you're the kind of person that you want to know what is the truth and how can we know the truth so that we can make better decisions, we can make better policies, so we can help yourself as individuals, your families, you can help your organizations, maybe it's your workplace, to do better, so you can help the countries to make better policies, then you will be interested in understanding truth and studying truth. There's a branch of studies on this called philosophy of science. So for people who are doing PhD, then they will take those sort of courses. But we're going to touch upon these issues of philosophy of science in this lecture today. So what makes social sciences very unique and very special is the nature of the social phenomena that we are studying. So we are studying people, we are studying organizations, we're studying societies, and we do know that people, organizations, and societies are very diverse, right? So you could do a study about, for example, people's preference toward organic food in, let's say, in some European countries. But the findings that you have there may not be the same as the findings that you will have if you do this research in Asia or in China or in Hong Kong, right? Because of the diversity of, you could say it like there are cultural differences, there are biological differences that drive the differences in what we think is the truth, right? So the implications of this diversity of the social phenomena, or there are multiple factors that will affect a phenomenon, is that there are always competing explanations. For example, if you say, eating chili will increase people's life, there may be a competing explanations. That is, eating chili does not increase people's lifespan. And also maybe the same phenomena can be explained by different theories. For example, how long can a human lives, right? You may have competing theories. You have multiple theories to explain what makes a person live longer than others, right? So, and all of these theories can be valid. So this is like the challenges really about doing research in the social sciences. The second part of this challenge in doing social sciences research is that human behavior change. Like, because we have freedom, we have creativity, things can change, people's behavior can change. So if you are measuring people's behavior, be it through survey, using experiments, or maybe you are using qualitative approach by interviewing people, the moment that you are trying to study these people or these organizations or the societies, then they can change. So when you start to measure and things start to change, then it's like shooting a moving target. Like, you want to measure it, but it keeps on changing. But this is not the case for people who are doing research in the sciences and engineering. For example, you can control everything in the lab. You can just change one or two variables and you can see how it changes, the outcome changes. So you're changing some of the stimulus or intervention, you can see how the outcome changes, and because you control it in a lab. But this is not precisely the case in the social science, because you cannot fully control everything. And also self-fulfilling prophecies. For example, when people read about something, and they may believe that to be a reality, right? For example, if you believe that eating spicy food, eating a lot of chilies can make you live longer, maybe you live longer not because of the chili itself, right? Maybe because you believe that chilies or spicy food because you believe that it can make you live longer, you feel happier. So it's because you feel happy, then you live longer. So it's not because of the chili itself. Or maybe because the chili itself or the spicy food has certain medicinal properties that is carcinogenic, that it can kill some bacteria, it can kill some germ, and that's why you are better protected from certain germs, bacteria, and that's why you live healthier. So that's the biological explanation. The previous one, that you believe, or maybe because you eat chili, you feel happier, you eat spicy food, you feel happier, is because of psychological conditions that you feel happy. And by being happy, then you live longer. That could be another explanation, the psychological explanation. So there can be many, but what we know is human behaviors change. And falsification is never permanent. So when we talk about falsification, is when there is a theory, when there is a certain explanation for why things happen this way, when you want to say you want to falsify, you are trying to provide an alternative explanation to undo or to prove that that original theory is not right. For example, people think about eating spicy food can make people live longer, right? Then you could have, for example, you do a large-scale survey and you collect like 10,000 of people who are primarily spicy food eaters or chili eaters, and they really live very long. Then you do another survey, still in the same country, and you find other groups of people who don't eat spicy or chili, and they still live very long. They still live very long. So the falsification of some reality is not. And let's say the first group of the people who eat a lot of chili, let's say all of this group of people don't eat chili anymore. They don't eat spicy food, but they still live long. So it's very difficult to falsify theory in this sort of manner, because human behavior changes. The third point is, in the social phenomena, there are multiple levels of what we can study, and this multiple level of explanations can be quite challenging to understand. For example, you can study, for example, about humans who live long. You can study the phenomenon of lifelong longevity. Longevity means people who live a long life. You can study longevity from a biological point of view, that what happens to the body. Also, what happens to the things that they eat, right? Or the things that they do with their body, sports, whatever, smoking. And also you look at the individual level, what happens to them beyond just biology. It all happens at the at the psychological, the sociological thing that happened to this person. You can look at the team, you can look at the organization, you can look at the industry, the society, the country. So there are many different levels of social phenomena. And what this means is that there are many levels of analysis that can portray a better reality than a single unit of analysis. So that's why multiple level of analysis is also very popular in social sciences. So the question is, what is the truth, right? Is everything that we hear, is everything that we see, is the truth? Just looking at this very funny picture, this guy on the left saw the wood on the floor as 4 blocks of wood, right? And the other guy from this side is actually looking at 3 blocks of wood. Who is right here? And who is wrong here? Please think for a few moments. So actually, the guy on the left, on my left, right, who say there are 4, it's true. From his side, there are 4 blocks of wood. And the other guy on the right, he's actually looking at 3 blocks of wood. So actually, both of them are right. But how do you resolve this everyone can be correct problem? And this everyone can be correct problem is very common in social sciences. For example, did you see the photograph of Prince Harry, or Prince William, sorry, the elder one, maybe Prince Harry, right? He was shown, and the photo was circulating a lot in the social media. He was shown like he was giving a middle finger. He was giving a middle finger to the people, but apparently from another angle, he was actually giving 3 finger, was giving like this type. But from another angle, he was like giving a middle finger to the people. So in a sense, in social world, in social science, social reality, there are multiple ways where you look at a phenomena, and it often depends on where you are and your understanding about where you are located and your own biases as a researcher, and that may affect the kind of conclusions or the truth that you're trying to study. Now, the next part is about philosophy. So this is the part of the philosophy of sciences that I talked early on. So you need some philosophical understanding to know about the truth, right? Now, there are 3 parts to this, right? 3 types of philosophical perspectives to truth. The first one is called positivism. So in people who believe in positivism believe that there is an objective reality. Like when we say, trees, right? There is an objective reality that I can see the trees out there from my window. There are trees out there, right? And if I say, there is wind, even though I cannot see the wind, but I can see the wind is moving the trees. So the trees are moving around, right? So these are more like positivism. So in positivism, it assumes that things exist, right? And that's what we call ontology. And in terms of epistemology means how we can understand about the reality. So the epistemology in this positivism is that they rely on a law-like relationships. Law-like means something that look like a law, like these things. If I drop my pen, there's a law of gravity. Because there's a law of gravity, that's why when I drop my pen, it will drop to the ground or to my table. So this is called law, a law of gravity. So in positivism, and right, where positivism comes from. It comes from the natural and engineering sciences. So they assume that there's a kind of a law that governs everything in this world. And we can study these things by creating some hypotheses about the reality, and we can test them deductively, which means that you come up with some statement, with some theory, with some model, you collect data to test whether this is the truth or not. Right? So in order for people to do positivism, then they will use quantitative methods using statistics, such as they will do survey. Of course, this is positivism for social sciences. You do a survey to understand about people's behavior, or you can do experiments. You introduce some stimulus or intervention and see whether that intervention will change people's behavior as an outcome. Or you can do some archival study. For example, the stock market contains like 20 years or 30 years or 50 years of data about each company that are listed in the stock market. And there's a lot of archival data there. The prospectus, the annual prospectus submitted by the company to the stock exchange, the value of the stocks at different day and different hours and different minutes, or even different seconds of the day. So there's a lot of archival data that can be studied. You can also do big data. So big data can be studied also using this positivism. The second one is, this is another example when we talk about positivism. So if you know there's this scientist from long ago, so if you learn history, when I was in high school, this was one of the most memorable part of the history course that I took. There's this guy called Galileo Galilei. He's from Italy. So Galileo Galilei, he was an inventor. And before he was famous, the prevailing theory or the prevailing assumption is that the Earth, the one on the left, the Earth is the center of the universe. So the Earth is the blue one in the middle, and the Earth is believed to be surrounded by other planets that are moving around the Earth. So this is called the geocentric view. When Galileo Galilei invented this thing called telescope, a kind of binocular that you can probe into the sky to look at the movements of the planets, right? And he will do this very precise measurement using the different lenses and different angles and different positions. He could measure, and then because he used this new tool, which is the telescope, he was able to see that actually the Earth is not the center of the galaxy. We are not the center where all other planets are moving around. Eventually, there's only one planet that moves around, which is the moon. This is called the heliocentric view. So the Earth, the blue one, the blue dot, there is another part called the moon, which we always see, is circumnavigating around the Earth. But eventually, we are not the core or the center of this universe, because we on Earth are circulating or circumnavigating around the sun. So there's a sun as the core or the center of our universe or the galaxy, and other planets are also circulating around the sun, and we are circulating around the sun, and the moon is following us together. So this is actually, Galileo Galilei is a very good example of what we call the positivism. So he shows that there's an objective reality out there. You can probe it, you can study it, you can examine it, and retrieve the evidence to come up with some conclusions about the truth about the world. So through his investigation using the telescope, he come up with the conclusion that actually the Earth is not the center of the universe. We are the sun is the center. So we are only a small part of it, and we are circumnavigating around the sun, and the moon is circling around us on the Earth. So this is just another example. So this is the guy who look at. So what Galileo has done is finding this objective truth. So this is called positivism, and this is facilitated by the scientific measurements that he has, which is using the telescope, which he invented. And Newton's law is another example, right? So when he was sitting under a tree, some apples fall down from a tree. So if you are a person who never observe, you're not a very observant person, maybe you don't You just take it for granted, oh, things will fall down. But he was a very observant, very curious person. And he started to think, why do the apples fall down? Is there something? Can it fall up? Why does it fall down? Right? So there must be something going on here that the apple will fall down to the ground. So he come up with this different kind of ideas about, is there really such thing called gravity? And actually gravity later become a law because of Newton. It's called Newton's first law. And then he tried to test this in different ways. He lay down on a big bathtub of water to see whether he will float or he will sink. And apparently he will find out that actually, the water will actually make things float or make things not easily going down to the ground. So there's some sort of mechanisms going on there with the water in the tub. But apparently, if you really see what Newton has been doing by understanding why the moon fall down, and this becomes the law of gravity, then you start to know that, hey, interesting, there's this thing called law of gravity, but there's this thing of law of non-gravity. Is there a law where there is no gravity? Right now we know it, because if you fly above a certain height, maybe, I don't know, maybe 100,000 kilometers above the Earth, you will have no gravity. And that is a time when you are floating. If you are the astronauts or taikonauts, you'll be floating around if you are in a very high altitude. So that is a time when, that is a situation when there is no law of gravity. Now, so what is this law of gravity and how generalized it is? So this is related to some limitations of a certain law or certain theory. He also talked about force, like if you play golf, if you know why rockets or rockets can fly, for example, or rockets can go to the moon, or you can have a car that moves, because there's this thing called force, and force depends on mass and the acceleration. So you can have a look at this. This is high school math. I won't go too much. And also another very important work from positivism is Newton's law on action equals to reaction. Because of this Newton's third law on action equals to reaction, we are able to fly using aeroplane. And this becomes one of the foundations of aerodynamics. So if you look at why a very big and heavy piece of metals, such as aeroplane, can fly, that's because there's this aerodynamic that's happening because of the shape of the wing. Because of the shape of the wing of the aeroplane is like this, the velocity, the speed on the bottom side, look at the green one, the speed of the bottom side will be slower, while the air that goes on the top will be faster. So because the air that goes here is slower than here, so then the air will move around, it will lift up the wing. So if you look at the wing, will, because of this shape, it will lift up and it will fly if you give some force. So it's very useful. And this is the theory from physics that are translated into something very useful. Now the challenge is that the question is, do we have theories like this in social sciences that can be very useful? And this is why a lot of people are doing research in social science. And that's why social sciences exist and continue to exist, because we are trying to understand the world, about the truth, and how we can make the world better. Excuse me. So the question is, do we have law, like gravity law of gravity in the social sciences? Is there, or are there laws, or law like truth, the truth that looks like a law for public policy and management? So this is the question that I'll ask you to ponder. The second philosophical perspective is called interpretivism. So if you don't like math, if you don't like numbers, if you don't like statistics, this is what you go for normally. You call interpretivism. So in interpretivism, the reality is actually socially constructed by humans, by our interactions, by the subjective meanings that we create with each other. For example, if we believe that there is a business opportunity to open a particular e-commerce or particular platforms, or even a particular shop selling certain things, if we if we meet regularly and we influence each other, we talk to each other, if we believe that there is opportunity, there is a market for this, then this becomes like a reality, right? So reality is not real according to interpretivism. Reality is constructed by us, by our interactions. So for example, if we all believe that eating spicy food, eating chilies will make we live longer, even though without hard evidence, if we believe that, then this becomes a reality that we share together. But whether we really live very long or not, that's another case. But we just believe that. So a lot of traditions, a lot of history, a lot of conventions of what people have done for hundreds of years, a lot of it is actually based on social construction, based on this interpretivism. Now, the challenge is, how do we go beyond this? But I'm not saying that interpretivism is bad and it's all wrong, because sometimes in many cases and in many contexts, you need interpretivism to understand multiple realities. And by understanding multiple realities, because I would see the case of a painting in this way, and you will see the same painting from different way, and you see different painting from different way, and we come up with different realities. And it is through understanding of different realities that we could make the world better, that we could test a certain theory, a certain policy, so we can make the world better. Now, in interpretivism, we rely on subjective meanings and what we call the inductive approach, to study something based on people's experience, about people's opinion, about people's understanding. And then typically in terms of methodology, people will use case study, people will use ethnography. Case studies, for example, if your case is some government departments, different government departments. So the organizations, the government departments as organizations, this could be your case studies. Let's say you compare immigration departments in Hong Kong versus police department versus fisheries department, and you see how do they do their work. So these are the cases. The cases are the organizations. You can also look at the cases as individuals, right? Now, this is just different level of analysis at individual or organization or something bigger. Or you could also do ethnography, in which you observe people in their natural behavior. So for example, if you want to study primitive people in the Amazons, so then you don't want to study the Amazonians from where you are sitting here in your office. You need to go there to the Amazon forest to look at these people. How do they live? And there's this very famous primatologist, I think her name is Jane Goodall. She studied apes, monkeys, right? So she's actually doing ethnography. So she spent like 30 or 40 years of her career in the forest studying the behavior of monkeys. She write down, she draw, look at the behavior of different monkeys. And she found out that, there are leaders among the monkeys. There are followers among the monkeys. There are one that is alpha male, very dominant. And there are others, through some fightings, others will become secondary and the others will become the alpha male. And what are their social relationships among these male and female and elder and younger monkeys? So she's doing it is called ethnography. Some people also do discourse analysis, for example. So there are different methodologies. Discourse is studying the language by understanding the social phenomena through language. For example, looking at the news media, the news articles published about a certain topic, and you can study them. So this is called interpretivism. So again, this is a very nice example to talk about interpretivism. It's a painting by a very famous Dutch painter. I used to live in Netherlands, in Amsterdam, so among other countries. So so in this painting by this, his name is M.C. Escher. So by this painter, when you look at his painting, it's very interesting. So he draw the reality through multiple interpretations. So if you're sitting here like where I am, you can see the guy in the bottom, he's climbing the stairs, right? And you can see other stairs. But you also need to tilt your head in order to see the other pictures of people walking, right? Of people walking down through the stairs, things like that. And also, yeah, so we could say that natural sciences depend on positivism. For example, there's some reality. Now the question is, can natural sciences also rely on interpretivism? Does statistics require interpretivism? So these are some of the questions that I would like you to ponder and think about as we go through the course. For example, you read a piece of news in a newspaper. It's about some taxi drivers who are not very happy with Uber. Uber is the app where you can get people who don't have a taxi license or who are not full-time taxi drivers to drive to provide a taxi service, right? So from the perspective of interpretivism, when you are reading a text, the meaning of this text can be very different from how I interpret this text compared to how you interpret the text can be different. So the two of you, the five of you, the 130 of you, when you read this text, you may come up with a very different interpretation about the meaning of the text. For example, the different emphasis, the different context, the different understanding about this news article. The third one is called critical realism. So in critical realism, the reality, there are some parts that are considered objective and real, and there are some parts that is depending on what and how we see it. It also assumes there are multiple realities like interpretivism, but it says that the world has different layers or different structures. So in critical realism, they try not to predict, but they only try to explain the reality. So they don't say we're trying to predict the reality, we're trying to explain the reality by understanding the different structures and mechanisms, by understanding something that we can observe. And they don't have any particular preference for methods. I'm in a lecture, sorry. So yeah, in critical realism, they look at the reality in terms of different layers. For example, the reality is something that sits out there. For example, a mountain, a volcano. So inside the volcano, there are mechanisms inside it that we cannot see, right? So that's called the real. And then there's the actual. The actual is something that really happens that we may or may not see. For example, if the volcano is erupting some lava, we may or may not see it, right? And we are not always there to see it. So that's called the actual. But what we can do, if you are following the critical realist perspective of the world, is you can take your binocular or your telescope and you go as close as possible to the volcano that is erupting, and then you are trying to study what's going on here. So this is called the empirical, something that you really observe. So according to critical realism perspective of philosophy, when you are studying something, you are only studying the empirical, something that you can observe. So what it is saying is there are other things that you cannot see, you cannot observe. The actual and the real are something that is beyond what you can see. So if you look at this perspective, then you would say that whatever you found in a research, you know that there are some limitations to your study, because what you are studying, the empirical, is only what you observe, what you can observe, or what you have observed. But there are others that you cannot see, and you cannot make conclusions about those that you cannot see or you haven't seen. You can only make conclusions or claims about the truth on the things that you have seen and you have observed. So this is another way to portray. I won't talk much about it. So what are the methodologies that you can use to understand the truth? There are different ways, but the primary one are this called the inductive approach versus the deductive approach. There's also the third approach called the simulation approach. And these are also used by computer scientists and social scientists who use computer simulations to understand some reality. And there's also a mix of inductive and deductive, which we call the abductive. But let's look at these first two as our main focus in the course. In inductive approach, you understand reality or the truth by making observations and looking at some patterns and try to come up with tentative explanation, and then you form your theory. So for example, you're interested about a theory about swans, right? Then you go out there to find some swans. Eventually, this is what has been done by a very famous biologist called one of them is Wallace, but before Wallace, you have sorry, it just slipped my mind. The founder of or the father of biology. So he went around different parts of the world to look at different animals, and he record them, and he make a classification. So that is actually a very inductive approach to doing research. So for example, you're trying to create a theory about swans, right? Then you will go and observe swans, right? For example, you're interested about some features about swans. And then you walk around to different places, different part, and you say, oh, you have observed 5 swans. And this swan number 1 to swan number 5 have white colors. And you start to have this tentative theory that swans are white. Swans are white. Because based on your observations of these first 5 swans, they're all white. And then you walk around and you found the 7th swan that has a gray color. And you start to revise, hey, not all swans are white. I need to revise my explanation here. So this is called inductive approach. So you keep on revising your conclusion or your explanation or your theory. And you start to say, hey, swans are not white. And then you keep on going until swan n, swan number n. Swan number n, it can be any. Swan number 100, swan number 1000, swan number 10,000, which means you have observed 10,000 swans. And you start to say, hey, actually swans, some of them are black, some of them are gray, some of them are pink, some of them are white, some of them are gray, some of them are whatever colors. Now you say, now I have a new theory of swans. And this is how it works in inductive. And the same way, you can observe about people's behavior. You can observe public policy makers or citizens' behavior inductively, and you come up with some conclusion at the end, and you revise some part, and you come up with some theory at the end. So this is the inductive approach. So inductive approach, you have some question that you want to answer. You collect the data. You look for patterns, and then you build your theory. So here, the example that I use is some theory on how artificial intelligence or AI will change public services. You can have a look at this example in more depth. However, in the deductive approach, it's very different. So instead of looking one by one and come up with a theory, in deductive approach, you start first. Yeah? You start first with having a theory of a swan. For example, your theory of swan say, all swans behave like this, and it has this kind of color, and generally it is like this. So that is your theory of swan, right? Without going into much detail. So that is your theory. And then you come up with the hypothesis that swans behave like this, swans have this kind of color, have this kind of capabilities, and then you collect data. You could observe, you could, I don't think they can fill in your survey, but you observe and collect the data. And after that, you confirm whether your hypothesis, whether your theory is supporting the initial theory that you have. If it's support, then you say, great, I get confirmation for my theory. If it's not supported, you say, too bad, this is not supported. I fail to support this theory. Or even you have another theory and you want to falsify this theory, or you want to weaken, or you want to show that that theory does not work. So you will do it this way. So you start with the theory, you collect your data, you set your hypothesis, you collect your data by observation, and you confirm or disconfirm that theory. Okay, clear? So in deductive approach, this is another example that shows that how we look at a deductive research. For example, your theory is that when public servants have public service motivation, PSM, when civil servants have public service motivation, they will be able to deliver better public service, enhance the public service. So this is the theory. So then you need to state your hypothesis. For example, your hypothesis 1 is public service motivation will be positively associated with higher quality of public service delivery by civil servants. So that is your main hypothesis. So this is called H1 or H2, hypothesis 1, hypothesis 2, hypothesis, depending on how many hypotheses that you want to test in a deductive research. But for every hypothesis, there is a null hypothesis or the alternative hypothesis, which says something that doesn't exist. So if your hypothesis, there is a positive relationship, then the alternative hypothesis, there is no relationship. If X could change Y as your hypothesis, then the alternative hypothesis is X does not cause Y, or X doesn't change Y. So this is always the case. So you have a theory, you have a hypothesis, then you collect the data, observation, and you test. You can do a survey, you can do experiment to test whether really, if people have more public service motivation, they will deliver better public service. And you can test this. And you can do statistical analysis to test this. And at the end, you confirm or you reject that statement whether public service motivation enhance public service delivery. So this is another example. You can have a look. So this is just an example of the output. So in deductive research, people always start with using diagrams or visuals to show the variables that you want to test and the hypothesis H1, H2, and the relationship with the arrows. The arrows are very important. Going this way or going both ways is very, very, very critical, very important. We're going to look at that in next week's lecture. And also, this is one of the typical outputs of hypothesis testing. So if you have that model at the top, one of the ways to present your statistical analysis result is using some table to show the hypothesis and the relationship with some numbers. For example, these are the regression coefficient. So we're going to talk about regression in week 4 and week 5. And these are the coefficient from the regression. We're going to talk more about that. So don't worry about these numbers at this point. So in relation to inductive and deductive, there are also two major research traditions that are aligned with this inductive and deductive approach. One is called the quantitative approach, or the quant. One is called the qualitative approach. So let me ask you, by this stage, the quantitative approach, to which philosophical foundations is this related to? And to which research methodology is this related to? Think about it. For the quantitative research. Okay. In quantitative research, of course, is related to what? Positivism, right? And it's also related to deductive approach, in which your data are numbers. You have theory, you have hypothesis, and the key part in quantitative research is the data is always in terms of numbers, or what we call close-ended answers, asking people yes and no, or 1 to 7. Do you want to be a civil servant? 1 to 7. Very much no, very much yes. Or, are you a kind of person who is very willing to serve the public, which is public service motivation? 1 totally no, 9 is extremely yes. So you ask people to. So this is the type of data you collect in quantitative research. In qualitative research, on the other hand, your data are typically text or even visuals, like some pictures, some visuals from social media or from magazines and things like that. So in qualitative data, your data are typically textual, can also be visual, but they're not numbers, that's for sure. That's not for sure. But you could also study visuals and text using quantitative approach, and that's another type of methodology. So the difference are you can read yourself. So typically in qualitative, you want to know something very specific. You want to discover something, you want to build a theory, and you want some explanation that are relatively complex that can be explained using words and concepts, and you don't use statistics, right? But in quantitative research, and this is the focus of PIA6204, because this is a statistical analysis course, in quantitative research, your purpose when you do quantitative research is you want to generalize your findings. For example, when you go to see a doctor and the doctor take a sample of your blood to know whether you have a disease or not, right? So the doctor will not take the whole body's blood, right? If the doctor or the nurse takes the whole blood from your body, you will die, or we will die, right? So what they do is they take a sample of our blood in a small amount and try to analyze this and try to generalize, just mean to look to say that this finding from this small amount of data applies to the broader population. That's called the generalization. So in this case, if you see a doctor or nurse and they take your blood, he's taking a sample of your blood to study and analyze this blood, to generalize this blood to your overall body, but not to the entire population. Impossible, because this blood comes from your body. So it can be only generalized to your body. But if there are, every one of us have a blood that have been taken and have been analyzed and is sitting somewhere in a repository, let's say open, what we call open science or open data, and everyone can have access to this data without knowing who we are as a particular person, which our Hong Kong ID or whatever, citizenship number, associated with this information on our blood, then people can analyze to understand patterns of diseases and why people get sick and how to find cure and how to come up with new medicine to cure diseases. So this is what we call generalization. So you want to test a theory because you have a theory about how the world works and how you can what is the mechanism in this theory and what are the hypotheses, and then you collect the data in the form of numbers. So and then there are some relationship among the variables that contain the numbers that you are capturing, and you do statistical analysis. So these are the two main sort of differences. So in quantitative research, you're trying to test certain claim or statements, right? For example, whether a certain behavior will make people live longer, right? A certain behavior will make people perform better in their jobs. And you also want to rule out alternative explanations. For example, if you know that people live longer not because they eat spicy food or because they eat chili, but maybe because they have regular exercise, right? So that is another explanation, right? So if you want to rule out that, if you want to say that there's this theory that eating spicy food or chili will make live longer, then if you want to say this is a theory, you need to try to rule out other alternative theory, alternative explanation. So alternative explanation is, for example, people can also live longer because they have a healthy lifestyle. They don't drink, they don't smoke, they have a regular exercise. But then maybe there can be other explanation because they have a good psychological well-being. They're always happy, they're always smiling, like me, for example. They're always have a good relationship with other people. This could be another explanation. So in quantitative research, you try to rule out this different explanation, but you can also combine these different perspectives to test in a theory to understand the phenomena that you are studying. But the key part is you want to test certain claims of theory. You want to rule out some explanations. So these are the typical output that you will have: some tables with some numbers, and also some constructs of variables that you are testing with different statistical outputs. So in quantitative research, your objective is to test causality, one of them. Causality means, does X cause Y? For example, if I give this medicine, are my patients healed because taking of this medicine? When I give vaccination to the bulk of the population, will they be protected against COVID? So this is actually testing causality. So because of this, something changed. But it could also be just something that are related, that are not causality, what we call correlations or associations. We're going to talk about that in next week's lecture. You also, for example, in quantitative research, you want to find some best fit. For example, you ask people's look at the example on the B1. So you give people some test to test their cognitive, their ability to think, right? And then you also look at the number of units per day. This units per day, let's say how many hours they study every day. So how many hours they study every day is the y-axis, and what is their test score in an exam, right? So every dot is every individual's score on the X and on the Y. For example, person number 1 study many hours a day, so very high on the Y, and also have a very high test score. So high on the Y and high on the X, so he will be on the top here. And there will be some people who spend very little time to study, and they also have a very little score on the exam. So on the Y and the X is very low. And you have other people in the dot. So in order to understand the patterns, you need to take a line. So this is what statistics is doing. And this is why you need to use a particular statistical software to help you make this line. So it will calculate a line that best represents the data that you have. But you can see that when you have a line there, it means that there is a pattern. But if you are looking at the one on the figure on A, in which there is just dots everywhere, everyone's data over there, but there's no particular pattern. It's just a round thing. And there's no way that you can draw a line. There's no way that you can predict any patterns. So a pattern like this, what we call finding the best fit for this equation, for this pattern, is what you will do in quantitative research. And you don't have to calculate. You can learn to calculate this by hand, but in this course and in most statistics course, you will use software to let the software do this calculation. And what is important for you is actually to understand what's going on, and how to do it and how to interpret it. The third one is actually statistical generalization. So once you study this, you want to generalize this to the population. Don't worry about the equations, the equations on the right-hand side. We're going to talk about that. I'm going to give you a very simple explanation to understand it. So the deductive approach or the positivist approach is also called the variance approach, right? So you want to understand the outcome. For example, why do people perform very well in their job? Why are some companies are very profitable? These are called the outcomes. Why are certain civil servants delivering a very good public service? Why are some countries very rich? So these are the outcomes. So in order to understand the outcome, you need to go back to understand what could possibly the drivers, and you go even back further. But in terms of how you study this kind of phenomena using a variance approach or deductive or positivism, you collect some data, you come up with your variables. So this variable 1, 2, 3 will supposedly influence or drive variable 4 and 5, and variable 4 and 5 will drive variable 6. So I use the examples of why certain apps are more successful. You can have a look at it yourself. In qualitative research, however, you interview people, or you use some media data or some observation data about some people that you are studying. You have some text that you are writing. You are trying to explore a particular issue, a particular question. You're trying to provide rich and thick explanation. Rich and thick explanation is some explanation that are very verbal, very long explanations, right? And you try to generalize to theory. I will not talk too much about this because it's qualitative for qualitative course, and I'm sure you can learn more about this. But once you have this textual data and you observe the data, you interpret the data. This is what I call interpretivism. You interpret the data, and then you code the data by hand or using some software. So in this example, I use a software, and you come up with some concepts from the qualitative data and their relationship. So this is one example. So this is one example of a new theory that people develop, that researchers develop using inductive approach. So this was published in a top journal in management. So you can just look at the style of it. The style of it is so different from deductive approach or quantitative approach that has tables, that have precise arrows and boxes and with some numbers. In inductive approach or qualitative approach, you come up with these concepts, with some process, with some mechanism, with some words. So this is how, and then you tell the story by writing. So this is called a theory that you develop using inductive approach. So this is another process of how people come up with a qualitative a theory that you develop using qualitative approach or inductive approach. So you interview people, you classify them into first order category. This is what people say, and those that are similar, you cluster them together, and you reduce their number or their dimensions to a smaller number in the second level or second order, and even reduce them to the third level or aggregate level. So this is another way of how people come up with a theory. So in qualitative approach or the inductive approach, or people call it a process approach, you start with some event of interest that you're trying to study, and then you try to see how this event evolves that produces different outcomes, and how this different outcome produces other different outcomes. Just one example, you want to understand why people resist to take some vaccination, right? That's your question. And then that is what you're interested in. And then you try to understand what is happening when people don't like to take vaccination. And because of these conditions, what else happened? So one outcome leads to another outcome leads to, so this is the process approach that people are using. So this is some other examples of or features of qualitative research, which is not the focus of this course. You can read yourself. It's very much rely on the researcher, your interpretation, and the data may always change depending on what new observations or data that come up. And your qualitative data can be words, pictures, or visuals, or audio, and things like that, which you can analyze. So I will not go too much, but if you have some qualitative data, you can code them and then come up with you abstract them, come up with some concepts, and then you develop some conclusions. So qualitative research is actually for theory building. You want to get something very accurate, very rich, very complex explanation that reads like a novel. But in quantitative research, so this is still qualitative. There's a lot of quotes from interviews that people have done. But there are some problems with qualitative research. So I think this is near the end of this, the first part of this lecture about truth. There are some problems with qualitative. It is less structured, which means that it's harder for you to find a topic that is manageable. And it's more difficult to get started because your data can be everywhere. The patterns can be very messy, and you need to talk to a lot of people. Sometimes it's very difficult to organize things together. And because of you are lacking this you're not so organized, you could miss out on something. And this will have some biases. And of course, remember, the researcher is a key part of the research process in qualitative research. So that's why the researcher's bias will somehow influence the outcome. And when you have the same data, a qualitative data, that is being interpreted by 2 or 3 or 5 different researchers, they may come up with different interpretations and different conclusions. So this is always the problem with qualitative research. So for example, if you are policymakers, you want to understand about your citizens' satisfaction with your public services. If you only rely on qualitative data, it's very difficult because people have different opinion and there are different interpretations by different researchers who are studying the citizen satisfaction. But if you use a very standardized approach to collect the data, to analyze the data, it makes life a lot easier. And you can compare these results across the years and across researchers. So it's a lot easier to make this comparison. So issues of consistency, reliability is a lot better in quantitative research. So consistency, reliability, comparability, replicability is almost impossible in qualitative research because those are what qualitative research cannot do. So qualitative research is good in exploring something, in identifying some new phenomena, in identifying some explanations that counter to what people already know. And you need so this is there are good things about qualitative. I'm not saying qualitative research is very bad, but there's a lot of good things about quantitative research. And a good researcher typically should have a mastery of qualitative and quantitative. But in this course, we focus on quantitative research. Yeah. So this is another examples of some problems with qualitative. It's also bound by language. So for example, if you are a researcher, you are studying the life of people in the Amazon forest and they don't speak English. I don't know what language is. Or you go to the remote towns in Africa and you don't speak the language. It's very difficult for qualitative. And qualitative research does not prove anything. It only explains something. It doesn't prove anything. So there are also some research in recent times that use big data, that use what we call computational linguistics. These are using a large scale and huge amount of textual or qualitative data. So the data is qualitative, but the approach is very quantitative, using statistics, using machine learning, using computer algorithms to probe into the qualitative data to come up with some patterns that are quantified, that are analyzable using statistics. For example, this is just a very simple analysis of Harry Potter, So I use a Harry Potter novel and I try to study what are the keywords in this Harry Potter novel. So I can see what are the keywords used. For example, Harry would be maybe the highest, or maybe Hagrid's, or maybe the name of the enemies. The enemies is, what's the name of the enemy in Harry Potter? That name will keep on appearing a lot. But you can also probe this huge information about Harry Potter's novel using qualitative approach in this, kind of what we call computational linguistics approach. So there are many new methods. There are many powerful methods that can be learned. I'll stop it here for this first part on the truth, and hopefully you enjoy this and you find this useful. You can always rewind this and to listen again, and I'm hoping that you will interpret or understand this lecture in connection with different parts that I will post for this lecture. So there are other parts such as theory, the hypothesis, and research questions and contribution that I will post in a moment in the following videos. Thank you. Enjoy. Bye.